Get this. Hello, this is a lab submission for graphics and multimedia. My roll number is 17BC1054. Today I'm going to be talking about modeling and about primitive 2D shapes. So basically I'm going to talk about modeling. Okay. When we have basically this is a picture, right? And when there's a picture and you really want to get it into like in the browser here, basically it's basically pixels, and here we have the x axis and here we have the y axis, and each one of these black dots that we see here are basically pixels. And the question is, how do we do this? This is done through a concept called modeling, where we take a real world object and we try to represent it here. Now, for example, this is a picture. Now, each one. Now, this is basically a array of If you look at it in a mathematical form, it is basically an array, a multi-dimensional array, where each which is basically, let's assume that this is 1500 into 500 pixels. Now 1500 into 500, you'll get some number of pixels, right? That's basically the number of elements in the array, and in each element we have another array which is basically tells us the color. Now, since we're working with the black and white model, we're working with values from 0 to 255, where 255 represents white and 0 represents black. For example, if I were to take some random pixel over here, its value would be somewhere around 0. Now, modeling is basically about how we can take a real world picture or object and then represent it in this form of pixels. Now, basically, in general, what is modeling? Now, when people, let's say, build a house, they basically need a blueprint, right? And in a blueprint, we basically have the dimensions of the house and the width, the sizes of the rooms and everything. And basically it tells us how to, how it's a kind of a blueprint where this is how we're supposed to build the house. And it's not in the actual form, but it's a kind of a reference we use to actually build something. Now, in here, what we're actually doing is, now that we have an image over here, we're basically finding reference points, where reference points are basically like the starting. Let's say this is a curve, and this is the starting point, and this is the ending point. Now, these are my reference points because these are where I draw the line from. And there are other things, like for example, when I look at this wheel over here, there's basically a wheel of radius, let's say some x radius or r radius, and when we're looking at, like, basically r is the circle of radius, r a curve with a particular a particular extent of how curved it is, an arc from where it starts to where it ends. Basically taking this picture and coming to getting it to a blueprint stage where you can kind of tell that, okay, these are the dimensions, this is how I'm supposed to create a particular model. And modeling is basically converting this raw data into a form that can be which can be used for representation. It's more like taking data and making it into a form which can be represented. Basically, it's a mathematical model, and that's what we've done here. We've taken this picture, we basically created a model for it, which is basically dimensions and everything, and we've used code, which is here. I've used the p5.js graphics library, and constructed this image. So that's what basically modeling is. And now talking about primitives. Primitives are like the basic building blocks here, and we work with 2D primitives, and as you can see, these are some of the 2D primitives that are here, and we've used these primitives to actually build this entire image. We have a lot of other primitives, like we have 3D primitives also, but for now we use actually 2D primitives, and we've basically taken a raw image, converted it into a analyzed it, and got it broke it down into small pieces, and we use primitives to actually build this image. That's what modeling is. I'm using the p5.js library, It's a library for JavaScript, and it can be used for running running graphics programs on the browser. The objective is to create a graphical representation of this image. As you can see, this is my output. Just hold on a minute. This is my output. This is the image that I tried to draw on using p5 library. Coming to the p5 library, we'll be mostly using 2D primitives. In my code, I have used extensively lines, circles, arc, etc. First, let me talk about line. In the code here, they basically used this function, and in the function, we basically have 2 points where we give 2 points, x1 and y1 and x2 and y2. These are the coordinates, and the p5 library draws a line. In the code here, you can see that I've used one of the lines over. I've used a line function here. Let me comment this. That's the bottom line. As you can see that this function can be used to draw a straight linear line. It cannot be used to draw curves. The next important function that I used is the arc. When I open the reference page, we can see that the arc, by using the arc function, we can draw a part of a circle, and we can specify the particular starting and ending points. Here, the first point is the the x coordinate of the center of the arc. The next one is the y coordinate of the center of the arc. This is the width, this is the height, and these are the starting and ending points, that is the angles. Let me comment this. As you can see that this line is not here anymore. I have used this to create the rim. Here, I basically the starting and ending points, that is the angles, are pi minus 1, quarter pi divided by 2.5, and here 0 plus quarter pi divided by 2.5. In an arc, this position is said to be 0, and this position is pi. It is reversed from what we usually do. Here I've added and subtracted a quarter pi by 2.5 to get this extra length. Leaving lines and arcs, I have used curves extensively. The p5.js library, the curves are a bit different. As you can see here, we have 4 coordinate points for each curve. The center 2, that is the x2, y2 and x3, y3 points, are the start and end of the curve. So therefore, these points are these are the endpoints of the curve. However, the first two, that is x1 y1 and x4 y, and the end, which is the x4 y4 points, are used to actually create the curve for the line. As we can see, these 2 points are 5,26 and 73,24 in this example. Now this point is 5,26 and this point is 73,61. These lines are actually used to bend a line to form a curve. As we can see in the example that I have used curves extensively, for example, the top of the car, the bonnet, the front, and also the headlights and rear view lights. I mostly used these 3 primitives: the arc, the line, and the curve, and circles, which I have used for wheels. Let me comment this. This is the backside wheel. This is the backside wheel. So let me refresh it. Now the wheel is not over here. Few other functions that I've used over here. I will discuss the code now. Here I have 2 functions. One function is the setup function and the next function is a draw function. The setup function is used to set up the canvas. Here I've used the create canvas function to create the canvas, which is the area in which we can draw our particular graphical representation. This is the canvas, the width, and this is the canvas height. This is the background color. I set it to 255, which is basically white. Now we have the draw function, which is the function that is responsible to draw the car that we see over here. Now this is I've divided the code into particular segments. Here I've used an important function over here is stroke weight. The stroke weight tells us the thickness of the line that has been drawn. For example, I've set the thickness of this line to be 8. This line is 8. Next, I worked on the wheel rim. This is the wheel rim on the back of the car. I've used an arc function. This is the center of the arc. This is the width and height. These are the starting and ending angles. I've used a no fill because when we use arcs, curves, and circles, they're basically filled with a particular color. This can be used to remove the default color. Then I've done the same code for the front wheel rim. This is the front wheel rim. I've used the arc again over here. Now for the wheels, I've used I've again used the arc function, but over here what I've done is I have used starting from 0 and ending at 0, so therefore it's a complete circle. It is basically an arc. The width and height have been adjusted based according to the picture that was given over here. It is not a perfect circle. As we can see that mostly the stroke weight is around 6, only the bottom are given more thickness. This part is the wheel behind the bottom part of the car, behind the wheel rim. It's a stroke with 6. This is a straight line. I've used a combination of lot of lines to actually draw the back of the car. As you can see, these are what these 4 lines do. Now this is where the curves start. This is the top back, this part. Now for this part I use the curve function and I've set its starting point and ending point here. There is 950, 175, which is this point, and 1375, 255, which is this point. these 2 points, that is 900 comma 330, compared with respect to 950 comma 175, comes somewhere around here, and 1400 comma 600 with respect to 1375 and 255 comes around somewhere around here. Now we can see with these 2 points by which the line is represented, and these 2 points which actually give the curve, we get a smooth curve on the back. Similarly, I've used the same principle to draw the top and front of the car and the bonnet. The front bumper also uses the same principle, which is the curve. Now I've started working on the window. As we can see, the window is also a curve with starting and ending points over here, and the the other 2 points coming somewhere around here. In the rear view mirror, I've also used a curve, but here I've made some small changes. These 2 are the starting and ending points. Now as we can see that the points that induce the curviness to the line come around here. The first point, as we can see, it's more curved towards this side, whereas on this side it isn't that curved. This is the rear view mirror code. Now I've also worked on the rear headlights and the front headlights, which are basically combinations of lines and curves. Here there's a vent on this side of the it's actually the indicator, and for the indicator I actually use a stroke width of 10, which is really big, so it looks more like a light, I guess. That's the code, and basically the concept, this is a lab experiment, and we worked on 2D modeling. So basically modeling is you kind of get this the objective of this lab was basically to work on modeling. Modeling is in graphics is a way to take a real world object and represent it in a graphical form, and to do this there is a mathematical form. To do this we have to take the picture and analyze the possible shapes and how we can represent each and every shape, or in the graphic the right word would be primitive. Each primitive can be we have to figure out how a shape, an entire diagram can be split into small primitives, and how and the code for each primitives. Once we write the code over in our code, we can generate the diagram, that is a graphical representation used from the code. That's it. Thank you.